Hello everyone. We are a team of MIT students and what we are about to present is a project we have been working on for the past year.
If I told you things I did before, told you how I used to be, would you go along with someone like me?
The project we have developed presents a way for people that are physically disabled to control a wheelchair using only their eyes. This is done by using a low-cost computer camera to capture a person's eye movements and an algorithm to track and translate this input into corresponding directions for wheelchair control.
The problem that led to this research was that there are people out there that probably due to an accident or some kind of disease are left paralyzed and rendered physically immobile. This is perhaps one of the most painfully cruciating conditions to be in. To be physically incapable of doing anything and losing control over your basic functions.
One popular case is the amyotrophic lateral sclerosis or ALS. It is a neurodegenerative disease that damages motor neurons in the brain and the spinal cord. As a result, people who suffer from ALS lose control of their muscles and become basically paralyzed. However, ALS does not impair a person's intellectual reasoning, vision, hearing, or sense of taste, smell, and touch.
Audio Jungle.
Since most of the people that suffers these conditions could still have control of their eye movements, it could thus be used in their advantage to provide greater physical freedom and to do things that they could not.
The eye-controlled wheelchair could provide a new hope for persons with physical disabilities as they can once again regain control of their basic mobility. This would make them less dependent on other people to live. It could also provide them with a better outlook and motivational uplift.
In developing the design for our project, we set out 4 objectives. First, we have to develop an algorithm that detects and tracks eye gaze position using an ordinary low-cost web camera. Also, we have to calculate the eye gaze direction and interpret it into movement commands. We also have to modify an ordinary wheelchair for motorized control, to which the eye tracking program will be integrated. For our final objective, we need to integrate an obstacle detection and avoidance system to improve the system's navigation.
User eye movement. The primary input of this system are the eyes. To control the system, the user simply stares at the direction they intend to go. Looking forward or up makes the wheelchair go forward. Looking to either side steers the wheelchair left or right. And looking down stops the device. Video camera. The most crucial aspect of our design is that it has to be cheap and easily accessible. Compared to other expensive and overly complicated eye tracking systems, we are using only a common web camera that are already included in most laptops. This camera is used to capture the eye movements done by the user. Eye tracking program. To analyze the video feed, taken by the camera and output it into intelligible commands, a visual processing algorithm was developed. It can be broken down into three parts: face detection and tracking. This part consists of looking for distinct facial features such as nose and mouth in a frame of the video in order to detect the presence of a human face. Eye detection, tracking, and isolation. Once a face is detected, the eye is located within the face, tracked, and then isolated to maximize computing efficiency. Gaze direction analysis. To determine the direction of gaze of the eye, the centroid of the iris is determined with respect to some reference point. The angle that is formed between the points represents the direction of the gaze. All these processes are done multiple times per second to continually produce an output. Microcontroller. To control the electrical parts of the system, an Arduino microcontroller is used. It takes the output of the eye tracking program and translates it to the corresponding movement. Obstacle sensors. Another input to the microcontroller are the obstacle sensors. These sensors are positioned around the base of the wheelchair. The microcontroller takes the reading from the sensors and changes the motion of the wheelchair depending on the presence of obstructions. Different positions of obstacles can be detected by measuring the proximity of the obstacles from each of the sensors. Motorized wheelchair. For our prototype, we converted an ordinary wheelchair into a motorized wheelchair. The motors are controlled by the microcontroller according to the eye motion and the presence of obstacles.
The success of this project could provide a brighter future for the physically disabled, since the design of the system is intended to be cheap and easily accessible, and the program can run on any computer. It could easily be replicated and it could be utilized by people all around the world.